This is a worked example on how to find the values of other circular functions using trig identities. So we've already seen problems similar to this where we used the x squared, y squared, r squared formulas and sort of found out these values of x, y, and r and used that to fill in information about trig functions. In reality, if you were solving a problem like this, you could use a variety of techniques from either Chapter 7 or Chapter 8, but I'm going to use exclusively Chapter 8 techniques just to kind of, prove a point almost. Um, so I'm going to try and avoid writing the x squared, y squared, r squared formulas as much as I can. And I guess really what we want to try and do first is we want to find the value of cosine, because if we find the value of cosine, then sine is the reciprocal of secant, and then cosine has its reciprocal. We can use sine and cosine to find tangent, and then we can go from there. So okay, I want to plug this value into the Pythagorean identity. So we have sine squared plus cosine squared equals 1. And so this gets us 13 over 5 squared plus, and then I'll call cosine x because it's just kind of, we're solving for an unknown value, and that equals 1. I can square this, and then I have plus x squared, and now this is going to be kind of awkward, but I'm solving directly for what this value of x squared is. And of course, I need 9 over 25, and I would need some other fraction, right? So I can just choose my fraction to have a denominator of 25, and then I need this to equal 1. And so I would think, well, what do I add to 9 to get to 25? Or if I did 25 minus 9, and that is 16. So this fraction is going to be 16. But then remember, this is my value of x squared. So these are the x squared values, but I want to know what x actually is. So I can take the square root of 16 over 25, and that gets me 4 over, not 25, but 4 over 5. Now, the one thing we need to make sure that we check is, remember, our theta is in quadrant 2, so we're lying in this quadrant right here. That has a positive x, that has a positive y, but a negative x. And so since cosine is a x value, this is actually going to be a negative, right? Because our formulas aren't necessarily strong enough to tell if we have a positive or negative. So our cosine value is negative 4 over 5, and so that gives us our first value, and I'll write these over here. Cosine of theta equals negative 4 over 5. Okay, now if you need to look at this scratch work, pause, because I'm going to erase it so I can do some other stuff. But okay, so now we have our value of sine that's given, we have our value of cosine, so let's find the other values. So first of all, tangent we know is sine over cosine, and so this will be 3 over 5 over negative 4 over 5. Excuse me. Dividing a fraction is the same as multiplying the reciprocal. So I should stick the negative in there. And then these 5s will cancel, and we're left with negative 3 over 4. Okay, so I'll write that down as another value. So we know tangent of theta is negative 3 over 4. After this, I'm going to erase this scratch work again. After this, sorry, I'm a bit under the weather. Okay, the rest of the trig functions are somewhat straightforward, right? So we know that sine of theta, or okay, let me do it the other way. We know that cosecant is 1 over sine. We know that secant is 1 over cosine. We know that cotangent is 1 over tangent. So if I want to find these other values, I can essentially just flip the value of the fraction over top of itself. So what that ends up getting us is, well, cosecant is the sine fraction flipped on top of itself. So that would be 5 over 3 instead of 3 over 5. The secant function, that's cosine flipped over itself, that's negative 5 over 4. And cotangent is tangent flipped over itself, so that's negative 4 over 3. And those are the final values of all of our trig functions. And so, again, is it easier in certain instances to use the x, y, and r formulas? Sure. Is it easier in certain instances to use the reciprocal formulas? Yeah, absolutely. Um, as an example here, I exclusively use the trig identities, but of course, you could use a variety of techniques in an actual problem. You're now equipped with the Chapter 7 material, the Chapter 8 material, so you can kind of attack these problems however you want. But in general, this is another set of methods you could use to solve circular functions, or that you can use. Lost my train of thought, but you know what I mean. Take a circular function and find the missing values.